Hello, you're going to open PDF B and you're going to find the notes on adding and subtracting radicals. And it may start here. What we're going to do is scroll down a little bit and we're going to do adding first. Um, I just think it's easier. Um, Adding radicals is like adding variables. If I take this all way over here, for example, if you have 3x plus 6x, then we know we can combine like terms and make that 9x. But if you have 3x plus 6y, I hope you recall that you cannot make that 9xy. Variables represent different amounts. Therefore, we cannot combine those. Well, radicals really work the same exact way. If I have radical 12 and radical 12, then I can say this is 7 radical 12. But I cannot put radical 8 and radical 98 and say that's 106. That's not, you cannot do that. So as long as you keep that mentality and you can remember that, then that's all we have to do with radicals. The only problem is radicals break down, and if they break down to be the same thing, then we must put them together. So this one, yes, they both are radical 12. We can put them together right away. But when doing radicals, you always want to see if they can simplify. So if we go back to our simplifying method, all right, I did 4 and 3. Pair 7 times 2 is 14 root 3 would be your final answer if I asked you to add those together. I cannot add, so if I go to problem 2, and I see that radical 8 and radical 98 cannot be, remember, radical 106. You cannot add them together. But what I can do is see if 8 can break down, and 8, 4, and 2, 2 and 2. So I get 2, the square root of 2. And 98, I'm going to break down to 2 and 49, and I'm going to get 7 and 7. That's a pair. So now I'm left with 7 on the outside and a 2 on the inside. And now I have 2 root 2 and 7 root 2. That's 9 root 2. And if you tested what 9 root 2 in a calculator, its approximate value is 12.7. The square root of 106, if I was to combine them and make this 106, is approximately 10.3. So I just want to prove to you and make sure you realize you cannot put them together unless you decide to break them down. Well, the same thing happens with any other root as long as, okay, so now we're looking at a cube root and a cube root. I could put them together if they were both the cube root of 10, but they're not. 10 cannot break down 5, 2. I'm not going to get any triplets. But if I do 80, let's do 8 and 10, 4 and 2, 2 and 5, 2 and 2, I'm going to get 3 2s. So now I have the cube root of 10, which is really 1, the cube root of 10, because there's a 1 in front of it. I have 3 2s, and there's a 4 here. So this is going to be minus 8, because 4 times 2. And then I have 5 and 2 left over, which means it's the cube root of 10 again. And now you can see I can do the cube roots of 10 are the same. So I can take 1 minus 8, which is negative 7, the cube root of 10. That's fine to have a negative. I mean, in this case, that is simply just a coefficient. So it's perfectly fine. All right, and let's look at one with 4. So 64, 4 and 16, I know this is going to be a 4 and 4. I'm going to stop there because that's going to get me, oops, sorry, nope, we're not doing cube root, we're doing fourth root. So 4 and 16, now I'm going to get 2 and 2. I'm going to get 4 and 4. I'm going to get 2, 2, 2, 2, and realize that I'm looking for 4 of a kind. So these get to come out. There is a negative here, so it's -2, but then I have the fourth root of, be careful, 2 times 2 is 4. 324. I'm going to do 4 and 81. I just picked that. I'm going to get 9 and 9. I'm going to get 3, 3, 3, 3. So I'm going to get threes that get to come out, but there's a 3 here, so it's minus 3 times 3 is 9, the fourth root of 4. And now I have a negative, and a negative makes -11, the fourth root of 4. So all you have to remember when you're adding or subtracting a radical, that the radical or radicand has to be the same. And that goes off the same thing of, it goes off the same rule of thumb as with exponents. So if they are the same, we can add them together. If they are different, you cannot. At this point, why don't you take a break and go back to the PDF? And this is your note sheet, and we'll go down to practice number 1, and you can practice adding and subtracting some together. Okay, so please try practice sheet number 1, and we'll go over those answers together when you're done. Okay, and then you're going to come back to the video. Thanks. All right, after you have done that practice video, multiplying radicals. And to be honest, there's a lot of ways to try. You can break down radicals, then multiply them at the end. I never really see the value in that. All I do is simply make them one radical and then break it down. So for example, root 2 and root 6, I could try to break them down and multiply together, or simply make it 12 and now just break it down underneath. So it's not going to matter. You're really going to break them down. So then when I get a 2 pair, then the 3. And so radical 2 times radical 6 is radical 12. What you can remember is if it's multiplication, there's really not a rule. It's that you can simply multiply anything that's under a radicand times anything under a radicand. If it's on the outside, you multiply it on the outside. So for example, if I have 3 root 6 times 2 root 4, 4 is not good, 5, maybe I'll do 7, okay? I can then multiply anything on the outside, so 3 times 2 is 6, but anything on the inside becomes 42. And then all you have to do is make sure it breaks down. Now this actually doesn't break down, so 6, so it would stay. When I look at this one, everything's on the inside, so I may keep it on the inside. 10 times is 150. X times X is X squared, and Y. And then I break it down. Well, since I already know it's 10 and 15, you're really just keeping it. And then remember, this is X and X, and this is Y. So because it's a square root, I'm looking for pairs. I have 5, they get to come out. I have a pair of X's, that gets to come out. And then I have 2 times 3, which is 6, and Y on the inside. This is a prime example of kind of what I just showed you. 3 root 6 squared is really 3 root 6 times 3 root 6. That's what it is. So anything on the outside, 3 and 3 get multiplied. Remember, that's multiplication. Or it is 3 to the power of 2 and root 6 to the power of 2, if you looked at our exponent laws. So it can look like that. Or you can write it twice. Just be careful. 6 times 6 is 36. And then, of course, I know it's going to pair off to 6 and 6. So now it's 9 times 6. It comes out of the radical, and that answer is 54. All right, so multiplication, again, if it's a cube root, as long, you cannot, I do want to bring up, you cannot multiply a cube root times a square root. So for example, you cannot do, you can, I keep doing that, sorry. I cannot do like the cube root of 6 times the square root of 8. You cannot make that, you know, the cube root of 48 or the square root because they're different. So you cannot multiply if they are different. You have to have the same indexes, and then you would get cube root of 250. And at that point, you can do 25 and 10, 5, 5, 5, and 2. That's going to be my triplets. And then 5 on the outside, cube root of 2 would stay on the inside. I want to cover, if you went all the way down the bottom of your notes, keep going. I'm going to look at one all the way down here, one, or I'll do 2 of them. This is where it's probably more common to use multiplication and addition, is when we're foiling or multiplying radicals, distributing. So right here, for example, I have to distribute this. Now, there's no number. There's a 1 in front and a 1 in front. So I really don't have to worry about the number out in front. Everything's in a radical. So this times this stays in a radical, and this times this stays in a radical. And now you're right back to the adding or subtraction. So if you would finish this, please pause your video. Do 12, you actually get 2 root 3, and when you do 18, you get 3 root 2. Don't confuse them. This is a radical of 3. This is a radical of 2. You cannot add them together, and that would be our final answer. And then let's jump over to this one, which would be like a common problem that we'll see. So what do we need to do to this? This is binomial times binomial, which means we're going to have to FOIL. So first times first is 4 times 3, which is 12. Then it's 4 times 4 times 2, radical 7, the 2's out in front. So 4 times 2 makes this 8, but the radical stays. Inside here, when I multiply, this is not in a radical, this is. So it's 3, the square root of 7. One's in a radical, one is not. And then last is this, in which you have 1 times 2 and 7 times 7, which is 49. 12 by itself. I have a radical and a radicand, both the number 7. So 8 plus 3 is 11 root 7. Please note you're not multiplying them. You would check later to see if 7 breaks down, but I know it doesn't. Before I do anything else, though, I know that the square root of 49 is 7. And 7 times 2 actually gives me the number 14. And so then now I can combine 14 and 12 and get 26 plus 11 root 7. Do not put them together as 26 plus 11. You do not add them. This is attached to the radicand. This is not. So your answer is 26 plus whatever 11 root 7 is. And that's a pretty common problem, so you will see those. And you'll want to go back to PDF B and now go back and practice on practice 2. And you should have some of those at the bottom down here, like 7 and 8. And we'll go over those. Thanks. I'll talk to you later. Bye.